Hey, Gen Z, when you've encountered an antique computer, ever stumbled upon those chunky, old-school ports on retro computers and wondered if they're some kind of ancient tech relic? No, those are Ethernet ports, and they're far from outdated. Ethernet is a network protocol that controls how data is transmitted over a LAN. An Ethernet network transmits data through a system of nodes, mediums, and frames. Nodes are the devices connected to the network, like computers, printers, and etc. These nodes are connected through mediums, the physical path for data transmission, which are typically twisted pair cables or fiber optic cables. The data that is transmitted within these mediums are called frames, each with unique source and destination MAC addresses for efficient communication. But why choose the wired Ethernet over the convenient wireless Wi-Fi with no cables? You've definitely experienced how your Wi-Fi signals just randomly disappear when you're texting your best friend. That will not be the case for Ethernet. Ethernet's direct physical connection to the network increases stability and reduces latency, enhancing real-time data transmission. Security is another significant advantage. Ethernet's closed system is less susceptible to interference and eavesdropping compared to Wi-Fi's open airwaves. Moreover, Ethernet connections aren't prone to signal issues caused by distance or physical barriers, ensuring consistent connectivity. These benefits make Ethernet a reliable choice for both home and professional environments. Picture a bustling financial trading floor where a single leakage or screw of data or a delay of financial decision will cause millions of money losses. Then, Ethernet is the right choice for its security and latency. Now shift to the intense world of competitive gaming. Definitely, you don't want to play an FPS game where you click the mouse and the pistol is fired only a second later. Here, Ethernet provides a gamer with a stable and interference-free connection, essential for maintaining an edge in fast-paced, high-stakes competitions.
However, for Gen Zs like you guys, your internet world is predominated by wireless Wi-Fi. But why? The core deficiency lies behind the physical constraints of the Ethernet, the wired nature. Wired Ethernet lacks mobility. You cannot freely move the position of your device, or else the connection might be lost or even broken. In addition, setting up an Ethernet network is more costly compared to that of Wi-Fi. Imagine how many cables are required. The scalability of Ethernet is also doubtful, as new cables are required to connect more devices, whereas you only need to click a button on your device to add to a Wi-Fi network. However, in Ethernet networks, the two most important challenges are IP address conflicts and data collisions. IP address conflicts occurs when two devices on the same network are assigned the same IP address, leading to communication issues. Collisions happen when multiple devices transmit data simultaneously over the same channel, causing interference. Ethernet addressing this with the carrier sends multiple access with collision detection protocol, which checks the channel before transmitting and delays transmission if a collision occurs. Modern full duplex Ethernet systems further reduce collisions by allowing simultaneous sending and receiving of data on separate channels. Let's dive into the specifics of CSMA/CD, the root algorithm that makes Ethernet work smoothly during the process. Communication begins with the sender checking if the line is idle. Once this is confirmed, the sender transmits data frame by frame. If the sender doesn't receive a response from the receiver or detect signals from another device attempting to communicate, the process continues as planned. However, if a collision is detected, meaning that another device is transmitting at the same time, the sender immediately halts its transmission. It then waits for a random period before attempting to resend the data. If the number of attempts to send the data exceeds a predefined limit, the device stops trying and waits for a new user request to initiate the process again. Else it will keep resending. This method balances the need for timely data transmission with the realities of a busy network environment. Last but not least, we've also provided a past paper question on CSMA. Pause the video for some seconds. And here, the mark scheme. Check whether you've got a full mark. Thanks for watching the video, and best wish for your journey on ASCS.